Hello everyone, my name is Varsha. I am from Sri Venkateshwara College of Engineering, Bangalore. Today I am going to discuss about the subject operating system. In that, the topic is CPU scheduling algorithm. Let us see the introduction to CPU scheduling algorithm. CPU scheduling algorithm are used to optimize the performance of a computer system by efficiently managing the allocation of the CPU to the processes. Each algorithm has unique characteristics that affect the turnaround time and waiting time of processes. Here is the shortest job next scheduling algorithm. There are three types. The first one is dynamic priority, the second one is preemption, and the third one is reduced waiting time. In dynamic priority, the process with the shortest burst time is given the highest priority. In preemption, if a new process arrives with a shorter burst time than the current running one, the CPU switches to the new process. Reducing waiting time results in reducing waiting time on average compared to FCFS. The next one is priority scheduling algorithm. There are two types. The first one is assignment of priority and the second one is dynamic priorities. In assignment of priority, each process is assigned as a priority. The CPU is allocated to the process with the highest priority. In dynamic priorities, priorities may change with time or as a process waits. Comparison of CPU scheduling algorithm and criteria. FCFS wait time is high. SJN short burst time get executed first. In priority, processes are scheduled based on priority. The next one is turnaround time calculation. There is a definition, formula, and importance of turnaround time calculation. The definition is the time taken to execute a particular process include both waiting and execution time. The formula of turnaround time is equals to completion time minus arrival time is a formula, and the importance of turnaround time calculation is indicator of CPU efficiency and process performance. Waiting time calculation. There are criteria effect on performance and reducing wait times are the waiting time calculations. In criteria, waiting time is the total time a process spent waiting for the CPU. In effect on performance, high waiting times can lead to inefficiencies and decreased system performances. Reduced waiting times. Efficient scheduling algorithm aim to minimize waiting times. And the next one is the code of the priority. Here is an ash studio.h int main open flower bracket. Here we are taking some inputs as bt of 20 comma p of 20 comma wt 20 comma and tat 20 comma pr 20 comma ijn total is equals to 0 comma pos comma temp comma average underscore wt comma average underscore tat. These are the some inputs in priority. And the next is printf. We have to print the entire total number of processes and scanf percentage d and n, close the braces and colon. Printf, again we have to print entire burst time and priority of that, and we are using here for loop I is equals to 0, I is less than n, I plus plus. Printf, once again we are printing slash n p of percentage d slash n comma I plus 1. Printf, we are printing the burst time and scanning that one bt of I. Priority, we are printing the priority, and also we are scanning that one. P of I is equals to I plus 1. Close the flower bracket. Again, we are using the flower bracket. Open braces, I is equals to 0. I is less than n, I plus plus. Open flower brackets. Pause is equals to I. For I is equals to, for j is equals to I plus 1. J is less than n and j plus plus. Open flower braces if PR of J, which is less than PR of POS. POS is equals to J, and then temp is equals to PR of I. Priority of I is equals to priority of pause. Priority of pause is equals to priority of temp. And temp is equals to the burst time of I. Burst time of I is equals to burst time of pause. Burst time of pause is equals to temp. And temp is equals to P of I. P of I is equals to P of pause. P of pause is equals to temp. Here we are closing the flower bracket, and WT of 0 is equals to 0. Again we are using the for loop. I is equals to 1, I is less than n, I plus plus. Again flower bracket. WT of I is equals to 0. For loop. J is equals to 0. J of I, which is less than I, j plus plus. Wt of I plus is equals to bt of j. Total plus is equals to Wt of I. Then we are closing the braces with flower bracket. And priority of pause is equals to priority of I is equals to priority of pause. Priority of pause is equals to temp is equals to the burst time of I. Burst time of I is equals to burst time of pause. Here we using burst time of pause is equals to temp is equals to P of I. P of I is equals to P of pause. P of pause is equals to temp. And again we are closing the closing with the flower bracket. Wt of 0 is equals to 0. Again we are also using the for loop, which is I is equals to 1, I is less than n, and I plus plus. Open braces, Wt of I is equals to 0. For loop of j is equals to 0, j less than I, and j plus plus. Wt of I plus is equals to bt of j 2. The total plus is equals to Wt of I. Here is the output of that code of priority and turnaround time. The output, enter the total number of processes. I am entering that one is 5, and enter the burst time, and the priority is P1, and the burst time of 4, priority of 2, and the burst time is 8, and priority is 1. I'm giving P of 3, and it's showing burst time of 9, priority of 4 is P of 4, burst time of 7, priority is 3, and burst time of 7, priority is 5. Here is the sum of the table. Processes P of 2, and the burst time is 8, waiting time is 0 and 8, and turnaround time, average waiting time is equals to 13, and average turnaround time is 20. You can see the output of the priority code. Thank you. Once again, let us see the slides that we are discussed till now. Introduction to CPU scheduling algorithm, and we also discussed SJN, priority scheduling algorithm, comparison of CPU scheduling algorithm and their criteria, turnaround time calculations, waiting time calculation, and the code for the priority. As here is the output. Thank you. I hope you all guys like this video. Please do share, like, and subscribe to my channel. Do comment in the comment section. Thank you.